We're given the vectored valued function r of t and asked to find r of 0, r prime of t, and r prime of 0. Where r of 0 would be a vector where the terminal point of the vector would be one point on the curve given by r of t. R prime of t would be another vectored valued function where if we evaluate r prime of t, it would give us a tangent vector to the curve. So r prime of 0 will be a tangent vector to the curve at t equals 0. And to find r prime of t, for review, we need to find the derivative of the x, y, and z components of the vectored valued function. Let's begin by determining r of 0. So find r of 0, we'll substitute 0 for t in r of t. So we'd have negative 2 times 0 squared minus 5 for the x component. The y component would be 3e raised to the power of negative 4 times 0. And the z component would be 4 times sine of negative 2 times 0. So simplifying, the x component would be 0 minus 5 or negative 5. The y component would be 3, since e to the 0 is 1. And the z component would be 4 times sine 0, and since sine 0 is 0, the z component would be 0. So again, the terminal point of this vector would be one point on the curve given by the vectored valued function r of t. And now let's find r prime of t. So we'll find the derivative with respect to t of the x component, the y component, and the z component. So the derivative of negative 2t squared minus 5 with respect to t would be negative 4t. The derivative of 3e raised to the power of negative 4t would be 3 times e raised to the power of negative 4t times the derivative of negative 4t, which is negative 4. The z component would be the derivative of 4 sine of negative 2t, which would be 4 times cosine negative 2t times the derivative of negative 2t, which is negative 2. Now let's go ahead and simplify this. So the x component is negative 4t. The y component would be negative 12 e to the negative 4t. And the z component would be negative 8 cosine negative 2t. So now to find r prime of 0, we'll evaluate the derivative at t equals 0. So r prime of 0 would have an x component of negative 4 times 0, a y component of negative 12 times e raised to the power of negative 4 times 0, and a z component of negative 8 times cosine and negative 2 times 0. And simplifying one more time, the x component would be 0, the y component would be negative 12 times 1 or negative 12, and since cosine 0 is 1, the z component is negative 8. So again, this vector here is a tangent vector at the point on the curve when t equals 0, and it points in the direction of increasing values of t. So let's look at this graphically. So the curve is graphed in black. R of 0 is this purple vector here. Notice the terminal point is one point on the black curve. And I graph the tangent vector twice. In component form, it would be this red vector here. But if we move the initial point to the point on the curve, notice how we can see it is a tangent vector. Let's pause this. So notice how this is the tangent vector. And it's pointing in the direction of increasing values of t, which means as t increases, the curve is traced in this direction, or has this orientation. So once again, the black curve is r of t. This purple vector is r of 0, where the terminal point is one point on the curve, and the red vector, graphed twice, is r prime of 0, which is the tangent vector. In component form, this would be the graph of the vector with the initial point at the origin. But if we move the initial point to the point on the curve when t equals 0, it would be this vector here, which we can see is a tangent vector to the curve. I hope you found this helpful.